Season 5, Motion and Forces, Physics and Necrotic World, Episode 109, Newton's First Law. Can I come in 2 minutes? Newton's First Law. Welcome, strangers. Okay, so you know with your graph, I'm going to reiterate because it came up, so I'm going to say it. The independent variable goes on the x-axis of the graph. The dependent variable goes on the y-axis of the graph. Okay, let's go back to Newton's first law. According to Newton, his first law of motion is that something at rest stays at rest. It stays at zero velocity. It doesn't move, yeah? It stays stationary. And something in motion stays in motion. So something moving will just keep moving at the same rate. Unless, and this is a big unless, yeah? Unless acted upon by an unbalanced force. Okay, so an unbalanced force is basically another word for resultant force. So basically, if there are no resultant forces, everything would just keep vibing to the music and generally keep doing what they're doing, you know? If the resultant force sums to zero, then if it started at rest, it would stay at rest. But if it started in motion, it will continue on its lovely jubbly path, journey, at the same constant speed and direction. So, if the resultant force doesn't change, what is happening doesn't change. If that resultant force is greater than zero, then that means that it would accelerate following the path of the resultant force. Okay, so it does this regardless of its starting point, being at rest or at motion. It doesn't matter, as greater than zero means acceleration. Being equal to zero means rest or continuation at a constant velocity, at a constant speed with direction mattering. Okay? See you next time at Physics and Necrotic World. This is your host, Rimona Christian, out. Season 5, Motion and Forces, Physics and Necrotic World, Episode 110, Heavy Lifting. Okay, welcome, strangers. This is like a shorter episode in comparison to other ones. So, you know, because YouTube takes longer to process shorts, because of my iPhone storage reducing drastically, I will have to combine this with the audio of episode 109 to post it. Actually, I'll be doing that a lot, with any episode as necessary. Like, I don't need to keep explaining this, hopefully. Probably not again. I'll just do it next time as required without full warning. But this time I'm just warning so you guys understand. For GCSE, yes, don't worry. There will be 20 episodes per season. There will be 14 seasons. There will be 20 episodes per season. I will make it happen. It will happen. I'll make it so. But I might have to combine to post. But they will be separate episodes as I promised. Okay. So say you want to lift 5 kilogram weights. That's easier to lift than, say, a goose feather, right? You know, the astronaut David Scott in 1971 on the Apollo 15 mission dropped a hammer and a feather on the Earth's belonging to Earth moon. Yeah. They hit the ground at the same time because of the lack of air resistance. Gravity was the force that ended up causing them to accelerate at the same rate, which is pretty awesome, you know? It's harder to hold the hammer away from you, like, say you hold it away from you, right? Stretch it out, arm stretched, holding a hammer, or 10 kilogram weight or something. It's harder to do that than to just dangle it by your side. Because the thing is, your shoulder acts like a pivot, which is pretty cool, right? Your shoulder acts like a pivot. Your shoulder acts like a pivot. Which means that the distance from the pivot is smaller. So the moment, the turning force, the torque that's acting on your muscle, will be smaller. So you need less force on your side in comparison to stretching out. Yeah? So, I mean, when you have your arm stretched out holding a heavy thing, the distance from the pivot is much greater. So there's a larger moment, which means that your muscle needs to overcome and like deal with a harder, larger force. Okay? That's why it's more tiring to hold something out away from you than to just dangle it by your side. Cool, right? Okay. See you next time at Physics in the Necrotic World. This is your host, Rimona Christian, R out.